So this is going to be a quick attempt at a build video. I am clueless about doing this, but we'll have a go. This is a Process 26 from Frequency Central, front panel and the PCB. It's quite a simple little module. On the back of the PCB are all on the screen print are all the parts. So here we've got a 5.6k resistor, or 5k6, which is 5.6 kilo ohms. 15k, 100k. Here we've got a B100 potentiometer. These are tall pot potentiometers. Another B100. Then we've got a TL072 IC. We've got a socket for one of those. I'll show you that in a minute, and so on. So everything's printed on the PCB itself. Really nice PCBs from Frequency Central. I've built quite a few of the modules and I really love them. They're all through hole. Although recently there have been some PCBs that have got surface mount components, but they're not difficult to do even with a hand soldering iron. And then the panel itself, which are always really nice. I love the fact that they've always got oval mounting holes, which makes life so much easier. They're really good quality. The screen prints are really nice. So there we go, that's that. Before we get started, what do you need? Well, you need a few little bits and bobs. You don't need loads of stuff. You need a soldering iron. This one's not on. I can touch it. I recently changed over to this type of iron, which has got a ceramic heating element, and I much prefer them because they heat up faster and they cool down quicker. There are very expensive models from some companies, and there are much cheaper models. This one's quite cheap. I think it was about £50. And what you're really paying for isn't the hot end, it's the other bit. So this is the other bit. I don't know if you can see that. I'm probably messing this right up because there's cables everywhere. But this is just a Chinese, I don't know, open source one. But it's really good because it heats up super quick. I'm not sure whether you can see that. But in fact, we're already almost up to temperature. It'll beep when it's at temperature. There we go. So we're up at 350 degrees, no problem at all. You can then adjust it. For this, I'm actually using leaded silver solder, which of course is not recommended, but it's what I have. So there you go. So that's ready to go. So I really like those because they're really quick to heat up and they're really quick to cool down. I've also got some cleaner for the end of the tip. So once it's up to temperature, you can give it a good wipe off, give it a little bit of a dip into that, and then it will just clean up the end of the tip really nicely, ready to go. And then of course you need solder. So different gauges of solder. This one's 0.6 millimeters, which is probably too small really for what I'm about to do. And remember, when you finish soldering, always keep the end of your soldering iron, with solder on it, because otherwise it oxidizes and it ruins your soldering iron. It ruins the piece. I've got a solder sucker just in case. This one's absolutely appalling. I've got one at work that's way better. This one's appalling because it doesn't grip very easily. It takes ages to get it to grip, and then pretty tricky. But if you do mess up your soldering, really useful to have. You can use solder braid as well. Somewhere I've got a cork with a piece of brass stuck in the end of it, which is really useful for cleaning out holes. You need some form of sprue cutter, or whatever. I've got a couple of different ones. This one's not as good really because it's got an edge there, so you can't cut quite as tight. Whereas this one's really good, but it's absolutely knackered, so it's blunt, which isn't great. It does help to have some flux of some kind. You can get flux in all sorts of different ways. You can get it in a paste that you can kind of just smear on. You can get it in like a felt tip, like this one, where it just kind of comes out. You can get a gel. It doesn't really matter, but some flux is really good because it helps it heat the part and heat the component. So before we start, one thing I like to do is clean this up. And I've left my cleaning stuff somewhere else and I can't see it. So I'm going to stop the video for a second, go find the cleaning stuff, show you how I quickly clean it before I start soldering, and then that'll just help. The other thing before we start is I've got all the components, all the parts ready in this box. I haven't actually counted them out or tested them or checked them or anything like that. They're just kind of sat in a box in their bags. But it's good to be a little bit organised and have something, you know, ready to go. It's good to have a little container if you're dealing with SMD components. And the other thing that's really, really useful are some good quality tweezers of some description. So there we go. That's kind of most of the stuff we need, I think. You need something to do the nuts up on the panel when you finish. There you go. That's the other thing. Maybe a screwdriver, a small screwdriver, just to do knobs up if you're putting knobs on. This one hasn't really got any. It's going to use potentiometers that have kind of got their own knobs. So there we go. I'll stop the video, go and find my cleaning stuff, and I'll be back in a sec. And of course, I forgot some stuff. The other thing you really, really need is a multimeter. This is mine. I've had it a while. It's a cheap Chinese thing, but it works fine. And it's really, really handy. Like this is probably the best tool you'll ever buy. This one's an automatic one, but it doesn't really matter. It allows you to test continuity, i.e. to see if there's a short circuit, or to see if a solder joint that you've done is working correctly. And it's absolutely vital. You need one of these, but they're not expensive. I think I paid about £15 for this, probably about 6-7 years ago. And it's been going strong ever since. So it's reasonably accurate. It's accurate enough for this job. So there we go. One thing I've started doing before I build a PCB is I've started cleaning them. And the reason for that is that sometimes I've just found, for some reason, there's a residue left on some of the PCBs. So these are just 70% IPA alcohol kind of wipes, and literally just wipe it on all over the circuit board. Give it a good old clean, and the alcohol's electric friendly, so it won't hurt at all. And there we go, simple as that. Just seems to help soldering. Now, I haven't got all the components in the box, to be honest. I think I haven't put a power header in there, maybe. In fact, actually, the power header on this is different to the build guide. Rick Holt from Frequency Central, there's really, really great build guides on the website, and you don't have to buy the module to read the build guide. You can look at it. So you just go find the module and then click on the read more label, and then you'll find the build guide, and you can go read them and get all your parts ready before you build them. There's a bit of a mark on there. Not sure what that is. Bit of a bubble. It won't affect anything. And you can see the trace really clearly where the kind of route of the electrons is going to go, which is really helpful. And I have damaged boards in the past and had to fix them and things like that. So there we go. Got a clean board. We'll let that dry for a second or two, and then we'll get going. So what we're going to do is we're going to put in the resistors first, because the resistors are going to sit lowest to the board. I can see on the board that there's probably more 100k resistors than anything else. So I'll probably start with those. So we'll dig out the 100k resistors, and I buy these in bulk. Rick Holt will tell you to get them from Tader.com, TaderElectronics.com, and I tend to buy a load at a time because it's cheaper that way because of the shipping. Simple as that. So I've got quite a lot. Looking at the board, let's have something to point with. We've got 1, 2, 3, 4, 5, 6, 7, 8. So we need 8 of these, and we could just tear off 8 and go for it. They're 1%, so the tolerance of these should be within 1%. Do you need to match resistors? I'm not sure. I don't know whether it matters. At 1%, it probably doesn't matter, but I have a habit of doing it. So all you need to do is set your voltage meter to read millivolts. There we go. This one's automatic, so it'll automatically set itself. Sorry, resistance. It's going to measure resistance. So this one's measuring ohms at the moment. These should be 100k, so we'll see what we get. So if we just line that up, we get 101, and give it a bit of time. Temperature affects them as well. 100.67, give or take. So all I do is go down the list and try and find ones that are similar. So those two are good together. That one's quite a lot. So I'm going to mark those two just with a dot and ignore that one. That one's the same. So this is probably not the most exciting YouTube in the world. But hey, we'll do the whole process. I think while I'm doing this, we'll probably talk about some other rubbish as well. So 1, 2, 3, 4, 5. Need a few more. That one's got a lot higher resistance. We'll leave that one. That one's about the same. 6. 7. That one's a little, oh, that's about the same. All over the place, that one. Let's leave that one. That one's about the same. So they're all about 100.8, give or take. So there we go. So I've marked those, which just means I can grab the ones I want. Always really tricky getting these out. 1, 2, ignore that one, take that one. There we go. And that one, and that one. And you don't have to do this. I haven't done this on everything I've built. It's something I've started to do more recently. And if there's transistors on a board, it's good if you can match them, but I don't really have the tools to do that. I'm not posh enough to have, you know, really accurate measuring gear. And this multimeter is probably not as accurate as it should be, but a digital multimeter, worth its weight in gold. It's my go-to when I have a fault or a problem. What I usually do as well, you can see it there actually, is I usually write on the strip what the resistors are, and that's just in case they get kind of separated. Usually put the watts or the volts, and they're 1%, these particular ones. They're supposed to be from Taylor. The rejected ones don't really matter, because at some point you can use those and just match them together. So they'll be matched and they'll be close in tolerance. And there we go. And what I do with those, once I've got the parts I need, is I put that to one side, knowing that I'm doing that bit, and it's all done. So what do we have to do? Well, we have to bend the legs and stick them in. The other way you can identify resistors, of course, is with the banding, but I've found that a complete nightmare. My eyesight's going, so it's really, really difficult. I tend to, and you don't have to, it's probably a bit, what's the word, obsessive compulsive, but I tend to put resistors of the same value the same way round. And what I mean by that is the 100k resistors that I'm going to put in will have the kind of reddy, darkish burgundy band on the same side. And the reason for that is if you make a mistake, it's much easier to see which resistors you put where. Now, I could have put that in there by accident, and that one's a 330 ohm. So I'm looking for the 100Ks. That one's 100K. That would have been easy to do, and then ended in disaster. That one's a 330. I wonder if I've got those two the right way around. Yeah, that one's 100. That one's 100. Always good to double check, triple check. There's nothing worse really than soldering it in position and then realizing you made a mistake, because that can cost you a lot of time. I'm sure I will make a mistake on this build. I literally make a mistake every single time I do it. And of course, talking to the camera, I'm more likely to make a mistake. So when I make a mistake, I'll show you how I try and sort it out. Sometimes successfully, sometimes not successfully. But I've never had to kind of like throw a board away in disgust. Like, you can fix everything. I have lifted traces. So lifting a trace is where you try and desolder it and the whole pad comes away from the board. It does happen. It usually happens, I think, and again, no expert, but I think it happens when you've got a dry soldering iron, there's not enough solder on it, or when you use too much heat, or a combination of both. Is probably the way I do it. But I have done that before quite a few times. You can repair it. I can show you one in a minute. So whilst I've got those like that, if I flip it over rather rapidly and push it down, we've got all the legs stuck out, and you can, if you wish to, bend them out. And what that means is they just hold in position a bit easier if you happen to move the board. The other thing you can use, which is really helpful, is blue tack. So I do use blue tack quite a bit to hold things in place. It's really useful. I've got like a trendy, clever soldering Ujima flip thingy. and I use that too sometimes. So here's a board that, here's a board that I messed up. So I've got a problem with this, and I'm not quite sure what it is. I've replaced the voltage regulators, and when I replaced the voltage regulators, I pulled the pad off. So on the back, it's going to look really horrible, this. But what you can do is you can join bits of wire to the traces, so you can kind of repair it. Now that's really ugly, but it does the job, it works. Having said that, this one doesn't work. That's a bad example. Anyway, you get the drift. My soldering iron's cooled down. And one of the things I try and do is think about how I'm going to actually solder it and what position I need it in. I'm probably going to go, where am I going to go? I might go down this side first, so I might change the angle of that bend. So I might go 1, 2, 3 there. Let's do those. And before we start, always clean the tip of your soldering iron. Give it a good wide puff. You don't have to be aggressive, you just need to get it all. And then tin it. Oh, that's interesting. Now you see, I've got a resistor left over. So either I miscounted or I haven't put enough in. So that's a thing that happens. That's why you count components out. And all you need to do is put a bit of heat on, and you're trying to heat up the pad and the component, and you should end up with a nice solder like that. That was a good one. They don't all go like that. And you can see the board's moving around a bit, which isn't particularly helpful, because what you don't want to do is when that's cooling down, you don't want to move it. You don't want the joint to move. Then you get a thing called a cold solder. So less than ideal if it moves around. If it does, just wait till it's stable, and then clean your tip, and then re-tin it, because we never leave it without it being re-tinned. Then I'm going to go down the other side and do exactly the same thing. So I'm going to go down the other side, just bend those in, get them out of the way a bit. Just go down the other side. So we've got 1, 2, 3, 4, 5 there. So let's do those. Try and get the heat onto both components. Can't get the soldering in. And it will just flow nicely. When it's the right temperature, it will just flow. Rick Holt's got a channel, Frequency Central on YouTube. Do go and have a look at it. He's better at this than me, because he probably does it a lot more than me. And he's using lead-free solder. And with lead-free solder, you definitely need to be hotter. So I actually asked him the question, because he was really fast at soldering and I'm quite slow. And I actually asked him the question, what temperature do you run your soldering iron at? And he said 400 degrees, which is quite hot. But for lead-free solder, you do need it hotter. So I'm running this at 380 degrees. I can get away with 360. I've done it at about 360 before now. But it does make it a bit quicker and easier if it's a little bit hotter. So they're kind of fixed in place just with one leg, which means I can inspect the board and see where I've missed one. I probably miscounted. 1, 2, 3, 5, 6, 7, 8. Oh, so you see, I've miscounted. I've pulled another resistor out that I don't need. Is it the same one? Yeah. So I've just ended up with a random resistor. So I did count them right. There we go. So that's that. Now you could snip these off now and give you a bit more space. In fact, let's do that, because we've got the other end to go. It's fine, isn't it? So they're all quite annoyingly in the way. It's quite a small board, this. As I said, these are my better snippers because they've got a flat edge, but they're absolutely knackered. I need a new pair. I went to buy a new pair and I bought the wrong ones. So these just snip off, and of course you want to try not to snip the solder. You're just trying to nip it just above the solder. So I'm clueless about all this, and I learnt it by looking up the NASA guide to soldering. It's online. If I had a brain, I'd post a link, but I'm not clever enough at YouTube for that. But yeah, the NASA actually publish their guidance for soldering, and on that document it tells you what a good solder joint looks like and what a bad solder joint looks like, and it's really helpful. Having said that, I have never reached the NASA grade of soldering in my life, and my solder joints are pretty appalling, but there you go. I'm trying to clean up my area a bit. One of the reasons for trying to keep your area a bit clean is you can cause a short on the board, because you can accidentally solder a bit of metal or a bit of old solder like that to the back of the board, which is less than ideal. So you really should kind of clear up periodically if you can. So then we're going to just do the other legs. Now, because that side's soldered in, I can just stand these up out of the way, which makes life a bit easier, to be honest. I've cut that one quite long. So let's cut that off again. There we go. So yeah, now it's quite simple. And also we can use the secret weapon. So I mentioned holding the board down, and if you've got nothing else, this is a top tip. So just take a few bits of blue tack. I think in the States they call it museum tack, but it's the same. It's the same stuff. It's really, really handy. So with that, you can literally just kind of stick your PCB down to your table. Sometimes it gets a bit melty, but it does come off quite easily. So there we go. The trendy soldering iron is probably cooled down, is it? No, it hasn't. We're good to go. You don't need a super steady hand, because if you're doing it right, everything just kind of pushes against each other. Now that one moved. When I took the soldering iron away, that one moved. So we're going to go back in. Just going to reflow it so it doesn't move when we take the soldering iron away. So always tinning the soldering iron. The reason you need that is because you want the component and the pad to heat up together, or as near together as you can. So I'm trying to get the end of the soldering iron into both of those. And you need to push enough solder in to make sure that the joint around the leg of the component and the pad on the PCB is kind of filled in, so you get good electrical connection. You can of course test it after. You can use the multimeter to test it. At some point it'll start getting a bit grubby and you'll start seeing kind of like black dots in your solder. It's usually the flux. I'm starting to see it now. So at that point, clean your tip. I think the NASA document says clean it after every joint, but that's a bit excessive for me. So there's one more just there, kind of that's in the way. I think there's just one more. Usually I use the build document, so I don't normally do it like this. Like I will read the build document so I don't make a mistake, but even then I make mistakes. In this case I'm not reading the build document. That's partly because I'm trying to do it on camera. It'll be an interesting exercise. I have read the build document though, and I did notice there was a bit of an oddity. One of the strange things about this one is it says to use just a male header cut to size for the power, and then I noticed on the PCB it's actually got space for a whole plug, so I'm not sure whether that's an earlier revision. So there we go. So they're on. Just cut the legs off with my incredibly blunt trimmers. Washing machine going in the background, tumble dryer. And there we go. So that's the first set of resistors on. And then we'll look for the next lot. So you just go through that process. It doesn't really matter which order you do it in terms of which resistors go in. I do like to start with the most resistors first, because it seems like the build goes a little bit easier. I don't know why. So we've got, where's my pointy thing? We've got a 330 ohm. So it's 330R, which means it's not kilo ohm, it's just ohm. We've got two of those. Can't see any more. And then we've got a 5.6 kilohertz ohm. So kilohertz? That's not right. Kilo ohms, sorry. 5.6 kilo ohm, 5.6 kilo ohms. We've got two of those. And we've got two 15K. So they're all, the rest of them are all two each. So not a problem. So once again, we'll grab the resistors, and I grab one at a time, not like all of them at once, because then you get confused and you forget what you've done. The next one out of the bag is 15 kilohertz. 15 kilo ohms. Why am I saying kilohertz? I have no idea. And we just go through the process again. With the higher value resistors, the tolerance is a little bit more forgiving, I think. That's my understanding. So we've got 14.95. 14.95. So we'll take those two because they're the same. 14.95. Is that within 1%? I can't even do 1%. Too stupid. It'd be 1.5, wouldn't it? 1%. I think. Is that right? Or 0.15. So there we go. But they're matched. That's the main thing. So these are the 15 kilohertz. Looking at the banding, I don't want to put them in the same way round as that because I can do actually. They'll be all right. Yeah, you can tell the difference. So we bend the legs, make sure they go in the right hole because this one, they're close together. Could easily get them in the wrong hole. That would be bad. And I've done it. We all do it. 15. We're doing 15s. 15 and 15. There we go. We'll use blue tack again because it's probably better for you to see. And the other bit of blue tack stuck to the back of the multimeter. Oh, actually, I won't do blue tack because otherwise I'll end up with bits dangling off the panel. Maybe I'll try to do the blue tack. There we go. So yeah, one of the reasons I do this is, well, I suppose start at the beginning. Why do this stupid thing? Why build synthesizers, Eurorack synthesizers or any synthesizer by hand? You can go to the shop and buy it. There are companies out there producing some really nice, really cheap modules. So you could just go down a shop, isn't it, and buy whatever you need. And certainly there are modules that I would like that aren't available as DIY projects. Like you can't build them, you have to go and buy them off the shelf. You pay a lot more. But for me, the reason I got into modular wasn't actually the music. It was the desire to make something, to build something myself and to have it work. And I've had a long interest in electronics since I was a kid. Well, I say interest, like I don't understand it. I don't understand electricity. Electricity is magic. I don't get it at all. And I still don't get it. I know it's got electrons flowing around a bit. That's what's going on. Like, I kind of know that. But I've always been fascinated by it. I've always been fascinated by model railways. My dad raised me doing model railways. And there's just something about electric current flowing into tracks or a PCB, flowing around and doing its thing, and creating motion and energy and things like that. I've been fascinated with it since I was a kid. And so there we go. As an adult, I kind of fell into this because I like music. I play the piano badly. I play the trumpet really badly. My dad's a music teacher. He's probably ashamed of me. But I like music. I've kind of dabbled with electronic music technology, I suppose. Kind of most of my life with digital audio workstation type things. What am I looking for? 5.6. Close. Those two are fairly equal. Let's take those. So dabbled around with all sorts of kind of music technology stuff my whole life. And I wanted to do an electronics project. I wanted to do some soldering just because I find it quite therapeutic. And I have problems with mental health, as many of us do. So 7 years ago, I discovered Eurorack, which was probably quite late. I mean, it's been around for a while. Dietrich Dopfer. invented the format and sells a load of beautiful modules, which are fantastic. So the dope for modules. I only have one dope for module. I'm going to flip this the other way so it's obvious that it's not the same resistor. I only have one dope for module, which is shocking, really. I should have more, just because he's the inventor of Eurorack. I think his kind of thinking was, let's make a big modular synthesizer at a size that people can stick in their bedroom or room, as opposed to the wall of synths that you saw in the 60s and 70s, where it was literally a whole wall of, you know, synthesizer stuff, which isn't that practical. I live in the UK, and the UK is, you know, houses are not big. I don't know what it's like in Germany, where Mr. Dope's from, but I guess it's the same. So he put together a set of standards basically for Eurorack, which I think it was basically based on size. And then I discovered it on the web purely by accident, and then went, oh, what, you can build this stuff? People make stuff and you can put it together yourself. And I was blown away by it, because obviously, you know, doing some music even all those years ago, or music technology, I was fascinated by those old synthesizers where they used to plug in things that look like telephone cables, telephone sockets, like they used to use on the old switchboards in the 1920s to the 1960s, 70s maybe. Absolutely fascinated by it. So I discovered it that way. And then I started, you know, as you do, you start going down the rabbit hole and looking for more information. The hardest bit I found was getting my head around the power. Eurorack is pretty straightforward. It's pretty simple, but the power demands of your case are the only bit that I find a bit confusing, because I don't, as I said, I don't understand electricity. Electricity is magic. How do you know about this stuff? But basically, you need to make sure you've got enough power for all your modules. Simple as that. And there are lots and lots of options out there for powering your Eurorack. Frequency Central, this company, they make some really nice ones actually. I've been using the Rootmasters. That was a broken Rootmaster that you saw there. But I've been using Rootmasters since I started, so that's 7 years ago, because it was the most cost-effective power solution I could find. The only drawback with them, we're looking for 330 ohms, give or take, but we want to match them. Well, those two are the same, aren't they? 328. Yes. Is that close enough? Do I need that to be closer? Yeah, they're the most cost-effective solution I found. So for £15 you buy the board. It'll cost you, you know, literally a £5 maybe in parts to put on the board, and then you've got a powered bus. I'll take those two; they look all right. And you've got a powered bus with a bunch of, which you can plug a bunch of modules into, and then all you need is an AC transformer for those. But on Rick's website, on the Frequency Central website, he has got a DC power supply, so you can use like a laptop charger, I think he suggests you use, but they're not, you know, they're not huge voltage, and I really like them because you haven't got to deal with mains electricity going into the case, so you're not going to blow yourself up. You know, you're talking about 12 volts at the end of the day, which is not a lot, and you're talking about a maximum of maybe 6 or 7 amps, not even that much. Maybe 2 amps in total. These are the 330s, so there's one, and I've put these the other way around as well, so they've got the kind of orange banding at that end, so again I can tell that I've put them in the right holes, hopefully. So yeah, I got into it and started looking at stuff, and then built the power supplies. I think I built the power supply first. Then I built another little power supply. It's got another one, which I don't think they make anymore. Which is designed just to do bench testing with, which is really useful. So it doesn't really power a load of modules, but it just it gives you the ability to bench test one module, so you haven't got the risk of putting them in the rack, which is nice. So try and hold that down with something, just for you guys really. Again, they've got lots of beeps from the soldering iron. That's it dropping temperature when you don't use it. That's what it's doing. That's why it's beeping. And that's designed to stop the tip from getting damaged. Because if you leave it hot all the time, it'll oxidise, it'll burn the solder off, and it'll knacker the tip of the soldering iron. So there we go. Yeah, so I got into it like that, and I built the power supply. It didn't work because I'd done it wrong, and then I reread the instructions and I fixed it, and then it worked, and I was quite excited because the joy of making something and then it working is what I'm addicted to. As I say, I'm not that into synthesizer music, strangely, although I'm quite enjoying mucking about with a modular synth. They're good fun for no other reason than they're really interesting. Like the way they work, I find fascinating. So there we go. That's all the resistors on. What else we got? So we've got 22 PF. Those are capacitors, and those ones are little capacitors. And then we've also got some big tall capacitors. Now, because that needs a socket, I think I'll do the socket first, then the capacitors, because I think the socket will sit higher than the capacitors. Maybe. Don't know. What I'm also doing is checking to see that the solder's gone all the way through the holes. If it hasn't, like there, that one doesn't look like it has quite. So what you can do, of course, is before you start putting other components on, because it's much easier this way, you can just reflow the top and just pop a little solder in there, make sure it kind of melts in, and just make sure you've got really good connections. Another one there that looks like it hasn't quite wetted through enough. So all that means is I haven't pushed enough solder into the hole. That's what's going on there. And then you can just reflow. They call it reflowing, basically just reheating it up. Top tip with reflowing, just so you know though, you do need some solder to reflow, and sometimes you may need some flux as well, because it helps the heat transfer. So there you go. So they're all nicely wetted through. Maybe there's another one just there. I'll just check that one. I find that doing this just saves you a lot of time in the long run. So if you do see any that aren't quite wetted through, before you stick the rest of the components on, you can just give them a little bit of heat, just to make sure you've got really good connections. If you're new at this, you could check your connections with the multimeter if you wanted to. So there we go. They're on now. Do we do the resistor? I think I'm going to put the socket on next, because the sockets they sit quite flat. And I think maybe the capacitor may sit higher than this. So start from the lowest things first. So these little sockets, again, this is from Tader, and they've got a notch. I'm not sure whether you can see. If I put that there, can you see? There's actually a notch on one side of it, so the notch is there, that little cutout there, and it's important, and I've done it so many times wrong, that you match that little notch up. So the little notch that's there, that little notch needs to match up with the little notch on the printed circuit board. So it needs to go in the same way. And then later you'll see that when we put the chip into that, the IC, integrated circuit, the notch, there's a dot or a notch on the end of the circuit, and it all matches up. Now you could try and flip this over and push it down to hold it steady, but what I tend to do is take something metal and just bend the pins over. So I find it much easier to get it flat to the board if I hold it against the board and then use something solid just to bend the pins over, just holds it in place really nicely, and it means it will be flat. And just double check I've got the notch the right way around, which I have. And again, this is now it's wobbling because obviously that thing isn't, can't sit flat now, can it? So blue tack to the rescue. Always use a blue tack. So what I've found with modular synth is that it's just really good fun. The other thing I've found is the community is amazing. So there's Facebook groups, of course. And if you just type in Eurorack, you'll be met with all sorts of Facebook groups. But there's also Modwiggler, which used to be called something else, which wasn't very PC. So they changed the name to Modwiggler. And they're really, really good source of information if you're new. They're so useful. And when you have a problem, to be honest, when you've made something or connected something or trying to do something and you don't know what you're doing, I guarantee there's people on there who know the answer. And if you're nice to them, they may even give you the answer. And they are really, really lovely people. Now what I've done there is I've done one, missed one, missed one. And the reason for that is you're less likely to get a solder bridge. And a solder bridge is where if you heat up 2 pads at once, the solder will join the 2 pads and you end up with a short circuit. So if you do one, miss one, and then do another one, these ones are cooled down while this one's hot, so you don't get a solder bridge as easily. It can still happen, but it just doesn't happen as easily. So if you want to avoid solder bridges, you can do it like that. Obviously, this is for the camera, not for me. I need to spin it around to do the other two. And that just makes life a little bit more pleasant for you because you're not having to sort out a problem after. If you do get a solder bridge, flux is your friend. So lots of flux, a bit of solder, and reheat it, and it will. You can generally clear them up. I have had some problems in the past though, because I'm not very good at fixing mistakes. Now that, there we go, make sure that's heated right onto the component. So they look pretty good. So that's the socket on. So the last kind of components we've got before we get to the potentiometers and the jacks are these capacitors. Now that's weird because I'm sure in the build guide it said you needed some other capacitors too, and there's nowhere to put them. Oh no, there, I can see them. I wonder if they have to stick out the backside, because there, those are electrolytic capacitors, cans, as they're sometimes called. I think they stick out the backside, so they're coming out this way, not the other way. And that makes sense because the panel's going to be mounted on this side and there won't be space for them. So that's where they go. So we'll do the 22 PF. Now, it says to use a different type of capacitor, but I haven't got any. I've only got these. So these ones are ceramic capacitors, and I think the ones you're supposed to use are not these, they're something else. I can never remember what they're called. They're like yellow things, but I haven't got any of them. So I'm going to use these, and it's probably not as good, and it'll probably explode into a million pieces and not work. We'll see. So as I said, these probably aren't the right ones. They're definitely not the right ones, because that is polarity sensitive. Now that's strange, because the ones on the build guide aren't polarity sensitive. So why are they polarity sensitive? So I think on that case I might actually go and consult the build guide, because he might have changed those for box capacitors. So I'm going to go and check, because they look like, oh, but they wouldn't be polarity sensitive either. How strange. Why is there a polarity on there? Right, going to go and check that. So back in a mo. So here's the build guide, and I really like Frequency Central's build guides. They come with great photos, good information, and the best thing is when you're looking at your bill of materials, trying to work out what you want, if you click on the thing, it will take you to a link on Tader's website or another website. And we can see that the right capacitor for this is a multi-layer monolithic ceramic capacitor, 50 volt, 22 PF. Now I don't have one of those. And I also know it doesn't matter which way round they go on the board. So I don't understand why the board has got a plus and minus on it. I don't know. It's random, so we'll ignore that. But I've read it, and it says down here, solder all resistors, solder the IC socket, solder both 22PF capacitors. It says nothing about which way around they go, so it really doesn't matter. So there we go. So I don't know why that's printed on the board. So, despite it saying positive and minus on there, I'm going to completely ignore that because it doesn't matter. I don't know why it's written on. What I will do is I'll put the capacitors facing a way that they can be read. So if I put them in that way, you can read the thing. Now, although these are not multi-layer ceramic capacitors, they are ceramic capacitors, and I think they'll be fine. They are 22PF and they are 50 volt. So not the recommended one, but it should work. It's probably not as durable. Like, it's probably easier to pop one of these capacitors, maybe, or maybe they just don't. They're not as accurate. They're not as stable. I'm not sure. As I said, it's electricery. I don't know, but we'll go with what we got. We'll see how that goes, and we'll see if it works. If it doesn't work, then there's going to be like a few options. We can wait a month and get the components from Tader, and as usual, I'll buy a load, not just one or two. And then you can desolder these. The easiest way to do it is snip them off, to be honest, and then knock out the old solder. There we go. So they're on. So yeah, they I don't know why it says positive and minus, because it doesn't matter with those. The other ones it does. So the electrolytic capacitors, it does matter, positive and minus. They are polarity sensitive, and you need to do it right, otherwise it will pop a capacitor. It'll blow the top of it into your face, which is particularly unpleasant. I've only done it once. You get a little puff of blue smoke. Quite exciting. I did it by plugging a module in the wrong way round, which is really fun. So it was just me checking I'd actually pressed record on the camera. So there we go, they're on. So the next thing will be the jacks and the potentiometers. Now I'll put all of those on at the same time, and I'll use the panel to squidge it down and make sure they're all flat and in the right place. I'm not sure what it says on the build. Oh, we'll check. What does it say on the build guide? Oh, it says solder the power header and both 47 UF capacitors. Okay, so it doesn't say what I thought it said. Now, the power header in the build guide is saying something slightly different to the PCB, and I didn't actually get the power header out, because the power header in the build guide says to cut one of those to one of these males, but I think they've revised it, because that looks like it will take a proper socket, a proper power header socket, and I would rather have a proper power header socket. And the reason I'd rather have a power header socket is because you can't plug in a power header socket the wrong way round. So to show you what I mean, haven't got cable to hand, of course, typical. But if you use the socket, it's got a cutout, and that cutout corresponds with the other end. I haven't got cable, but I have got a socket, a plug, so I can show you. If you're new to Eurorack, this is kind of the standard. So there is a piece there that plugs into there, which means you can't plug it in the wrong way around, as long as the cable's set up properly. So red, negative, there's two arrows on here as well, then everything's good. So I would rather put that on than what it says in the build guide, which is to cut one of these and make like a single row. The single row is useful though, because sometimes it saves space on the back of the board. Sometimes you haven't got space in your rack to plug in one of these. So we'll see what it looks like. So it's saying there's the notch guide, and negative is there. The arrow on the plug lines up with that negative rail as well. So there, that's why. So you can see that sticks out past the PCB, which means if I put that into the rack, it's going to interfere with the module next to it. So that's why you can't do that. So the build guide in that case is correct. So we'll have to go with the build guide, which says take a male power header, a bag of these. Again, buy them in bulk. Just buy everything in bulk, because these are like pennies and you use them all the time. So it's not worth messing around with. You may as well just get a load. So what we're going to do is a single row of these. We could do a double row maybe. So we need 1, 2, 3. I should know this. It's 10, so it's 5. So we need 5 of those. 1, 2, 3, 4, 5. And the simplest thing to do is just do one row. So it's one row of those, and they want to be this way up. So do we want to do that, which is the normal way of doing it, or do we want to do that? We definitely want to do the first option, because the second option will be a problem. Now I'm going to put it on that row because I think that's going to be better. The reason I think that's going to be better is because it's less likely to interfere with the top of here on the rail when it's in the rack. These are tricky to get lined up. They always are tricky to get lined up. You can use your blue tack again. You could also use some tape. And I have used tape in the past, but I seem to have lost my tape now. Oh, there we go. Doesn't have to be electrical tape. You could use some masking tape. I've used masking tape in the past. Just don't use sellotape because it'll melt. So you can use a bit of tape just to get it started and flat. And what I will do is I'll only solder one pin, because if I solder all the pins and it's not straight, it's going to annoy me. So I'm just going to solder one pin. So that's pretty much right angles. Right angles, give or take. Just nudge it a little bit. There's a right angle. So right angle, solder one pin, see if it's right, and then check it and all that malarkey, and then go from there. Oh, that's trying to get back up to temperature and I'm trying to clean it. There we go. So just one pin, try not to move it and wiggle it. They take a while to heat up some of these. There we go. Give that a second. Whip the tape off and see if that's at 90 degrees. Yeah, there we go. Give a take. I mean, you can be really anal about it and check. Close enough, that'll be fine. So again, I'm going to use my trick of not soldering the one that's next to it because it'll still be hot. So I'm going to go to the one, miss one out basically, go to the next one and then go back. Sometimes, see how that's not, yeah, sometimes they take a bit longer to heat up these. There we go. And then what happens is it melts the plastic on the other side. Yay! That's a pretty normal thing. That's a thing that happens. So really you don't want to overheat these, but I always do. Oh, that's horrible. Fix that up a bit. Right, again, solder bridge. Ugly. I think the ones that take more heat are the ground pins, because the ground on the board is a longer circuit, is a longer connection if you like, so it dissipates more heat. So you always need longer to put the heat on, or you need a hot temperature on the ground pins. And on a Eurorack system, don't like that solder, that's horrible, that one. On a Eurorack system, the three in the middle, 1, 2, 3, those three are grounds. So they always seem to take a bit more heat than the others. So there we go. so it hasn't melted it too badly, and that's fixed on really solid. And then it also said do the electrolytics that are on this side of the board. So these are on the other side. Now, that's not normal. I haven't seen that on any of Rick's other boards, I don't think, ever. So the electrolytic capacitors, these ones are 47 UF 25 volt. They do need to go the right way around. So electrolytic capacitors, aluminium can capacitors, I think, can capacitors, some people call them, they have a positive and a negative. So this gold band here is the negative. The short leg is the negative. So on the board, it quite clearly says that that is the positive leg and that's the negative. Yeah, the square pad is the convention. So that's the positive leg. The round pad is the negative leg. And the same on the other one. So we need to get those the right way in. So that's positive and that's negative. So positive leg is there and the negative leg with the minus symbol is there. And they're both the same way round. We'll pop both those in and then we'll check and make sure they're both the same way round. And then what I often do is I'll actually check the build guide picture. So Rick very kindly does put a picture on the build guide of those capacitors. Frequency central is written there, and the negative is that way. So it's that way. And if we look at that, frequency central is there, and the negatives is that way. So yeah, that's the right way around. So it's always good to double check that kind of thing before you solder it. And this is going to be a nightmare to hold. So this is where my blue tack comes in. A bit more blue tack. Might need both bits of blue. It's cold today. This blue tack's not very tacky. There we go, that'll do. Just to hold it in place. And then try and heat up the pad and the leg. And again, the little trick, I'll go straight to this side, then I won't do the same one. Not hot enough. And then we're hot enough. I go back, trying not to get a solder bridge basically. Give it a second to heat up. Oops. Ended up with a mess. Yay. Oh, what a mess. That's gone very badly. There we go. So that's happened because I haven't got the heat into the leg. And again, it's the ground, because the ground is a longer circuit, takes longer to heat up, or you need to use a bit more temperature. That's really horrible. I've made a mess of that, and nothing I do is going to fix it. So let's try getting in there, wick away some of the old solder. That's a bad joint. That's particularly ugly. I'm not sure why that went so badly. This is where flux could be your friend. And if I could be bothered, get the flux out. I think it's me introducing the solder too early before it's hot. Now I've got the same problem on that one. So let's use a bit of flux, because that's ugly. I am at temperature. Let's go a bit hotter. Go a bit hotter and see if that helps. Sometimes you go too hot and you end up with solder everywhere and splatting all over the place. Yeah, that's helped. Still a bit ugly. Still not the prettiest, but I don't think it's a solder bridge. So if you're doing this and you're worried that you might have a solder bridge, i.e. a short circuit, and check it real simple. Turn your multimeter on. On this one I have to press this button to go to the next menu. And now I'm in what's called continuity mode. There's a little symbol up there, like a little Wi-Fi symbol. And when I touch the two probes together, we get a beep. So if we want to see if there's a short between those two components, you just touch one on one leg, one on the other. And because it's a capacitor, check it both ways round, because I wasn't particularly careful. And there's no beep, there's no short circuit. If you were to connect it on two parts that are connected, like that, like on that leg, you get a beep. So you can check whether you've got continuity. You can check that the solder is good, or that the part is good, or whatever. That is really bad soldering. I'm really ashamed of that. Don't know why. Sometimes that happens, but I'm pretty sure there'll be good electrical connection, and ultimately that's what matters. I could clean it up, but it'll take me ages and it's probably not worth it. It'll be fine. So there we go, and then we're on to the jacks and everything else. So the jacks and the potentiometers. So the potentiometers, it says B100K, and on the build guide it said the tall type. These aren't as tall as the tall type. The ones that Rick recommends are the Sunghui ones, which are taller than these. He recommends those for two reasons. One, they're a little bit taller, and two, they have a white dot on the thing. Now there's space for a white dot, and I will probably paint a white dot on these because it is really annoying not knowing which way they point. But for the cost of a bit of Tipp-Ex or paint, it's not hard to do. So I probably almost certainly will pop a little white dot on those when I'm done, and then it'll be easier to read where the position of the potentiometer is. So there's three of those, and you could just pop those on, check them, solder them, blah blah blah, but I'm going to put the jacks in as well. They sometimes take a little bit of effort to push in. Make sure they're sitting flat, but when we put the panel on, that'll also make sure they sit flat. So these just hold them in place, and then these are the actual electrical connections, the little three. So make sure they're all poking through, which they are. I did it the other week. I did a bad job. I tried to do one and I messed it right up because it was a fader, and the fader didn't didn't poke through. I bent a pin and I soldered it in place, and then obviously one of the pins wouldn't come through, and that was a mistake. How many of these do we need? 1, 2, 3, 4, 5, 6, 7, 8. Gosh, that's a lot. 1, 2, 3, 4, 5, 6, 7, 8. So again, count them out, just helps you. What you have to be careful of with these Phonicon jack sockets is this leg. I think it's the ground, has to go into a little hole of its own. So make sure that it's in that little hole. So you can see which way they go up on the board. It's really simple. And I have had some builds where actually the jack socket has caused the problem. I've had a short underneath because I've used too much solder. So you either get in trouble not using enough solder or using too much solder. You can't really win. And I had to take the jack off. It's happened a couple of times actually. And I sometimes wonder if it's a faulty jack, but usually I think it's my soldering. I don't think you often get a faulty jack socket. You could, of course, test them before you put them in, maybe. So they're all in. They're not very lined up. So this is where the panel comes in. So this is the point where I tend to put the panel on. And that means that if the panel's on, everything should line up. Now, that's interesting. The potentiometers don't quite hit the panel. They sit below the panel. That's quite unusual. Don't normally see that. They usually sit up to the panel. So that might be interesting. In that case, it may be a bit tricky, this, because normally what I'd do is I'd use a peg or something like that to clamp both sides of it. But in this case, I can't do that because it only lines up on one side. So what I think I'll do is I'll solder a couple of jacks in place and then use the nuts on the jacks to hold it all in place, if that makes sense. Or maybe some tape. Let's try some tape. Let's go with the tape. I think the tape might be better in this case. So we'll go with some tape to get it all straight and lined up. That's very unusual. I think it'll hold the jack socket, the jacks in place to get a couple soldered, and then I use the nuts on the jacks to hold it in place. Never had that before. Usually they sit flat to the panel, but not in this case. I'm hoping they're going to be alright. So let's chuck a couple of these on. If in doubt, carry on as if nothing's wrong. Realise your mistake. Spend 6 weeks undoing the mistake. Yeah, that'd be fine. Let's do 3. I think we'll do 3. So we're going to go ground. Do a few grains on there. Not enough. Let's do 3 grains. I always find these a bit tricky as well because they take a lot to kind of heat up as well, and you want it so that the solder's melting on the pad, and because it's a big pad, it takes a little while. And then the other problem is that then you end up melting the socket. Which other one did I do? That one. Let's do that one. And then if you push, like I have there, if I push the pin of the socket, it moves. You can end up with a cold solder joint. So just go back in, reflow it. Keep the heat on. And this one. I haven't even told you what this module does. That's partly because I don't really understand what this module does. I don't understand what most of the modules do, to be honest. I'm clueless. I just build them and then fiddle with them and see if they work. This one is, I think it's based on a Profit, a sequential circuits Profit module, possibly. And it says that you can use it as a mixer. I don't need another mixer, but you can use it to attenuate voltage, and more importantly, you can use it. I think you can use it as an offset. And what I needed was an offset. So I've got other attenuators that can attenuate without a problem. And attenuate just means turn it down, control the voltage. I've got other modules that do that and do it very well. What I needed was something that can offset. So if you imagine you've got 1 volt, an offset allows you to increase that to 2 volts, and you've just got a 2 volt steady source, and that's what I really need. So I'm hoping it does that. So that's what I kind of need in the module, in the Eurorack, which is why I've bought the module, and I think it does that. Now I think it also does negative offset, possibly, not just positive. Oh, see, now that didn't work, did it? There we go. Let's try that again. Put them back in. Put them back in. Put them ones what I haven't soldered back in. Put the panel back on. Put some nuts on the panel. That's what I was trying to do. But when I pulled the tape off, it pulled everything apart. So, hopefully with a wiggle, that'll line up, which it does. Now, of course, I haven't got a nut to hand. Didn't do that, did I? That would have required planning and forethought and things like that. So this is a little trick though, isn't it? So what you can often do is just get some nuts and hold everything in place with some nuts. Of course, I haven't soldered all of them, so I can't remember which ones I've soldered. Soldered that one, so we'll put a nut on that one. There we go. Stick a nut on there. Doesn't have to be tight, super tight, just needs to hold it on and hold it together. And I did that one, just that one. So So we'll put a knot on there. It's good just to take your time with this bit though, because I have done it in the past where I've ended up with a panel that's kind of a bit higgledy-piggledy. That's not so neat, and it's really annoying. You can usually fix it, but if you've soldered everything, that's quite a difficult fix. Whereas if you take your time, I've soldered that one. If you take your time and do something like this where you can hold it all together, at least you can check and stuff before you get there. So I don't really need these to be super tight. It's going to be tight enough. So now, because they're on, that you can see that the potentiometers are in the right place. If they're not quite centered, we can just kind of center them up. There's a bit of wiggle room, because if they're touching the front panel, when you turn them, they'll bind, and that's really annoying. So now we can solder up the potentiometers and make sure that they're where they need to be. Weird though how they don't quite hit the thing. They're not. These can be a pain as well to get heat in and to get it to flow. I like to go up inside the kind of gap bit, but you need quite a bit of solder on your iron to make the thing work. And you can just feed the solder in and around, and that'll just hold the potentiometer in place. That's all they're doing. I don't think they make an electrical, well, they don't make an electrical connection at all. These bits, literally, they're just so you can rag on the thing without it falling out. So that's that. So that's one leg soldered in place. Now we need to do the electricals and the electrical connections and the other bit. So I'm just going to do the middle pin of all of them first. And then that way, again, just trying to avoid getting a solder bridge really. I think it's time I cleaned my tip properly. Nice and shiny again, because it was definitely working better before. They do kind of get caught. I think it's the rosin that they put in the solder. I think it gunks up your soldering tip eventually. So having some cleaners has been a real boon. Although I have misused the cleaner. I've put it all over the soldering iron, and I think you're only supposed to put it on the very tip. And I've got one end that's really gunked up with it. So there we go, that's that, which means I can spin it around. I can do the other holdy leggy thing, the thing that holds it in place. Oh, that's a bit ugly. Tidy that up a bit. Make sure that heat's flowed in there. Follow my own advice when I said I need a load of heat. I've certainly gone a lot neater than the electrolytic capacitors. Really unusual. I've never had that with a capacitor. I've had it with these bits, but not with a capacitor. Weird. While we're here, I'm going to go on this side because it's just accessible and ready to go. So that's the other pin for the potentiometer, the other bit that carries current, the electrical connection-y bit. That doesn't have enough solder on it because I'm looking at a different angle. I can see that now. I'll let that heat up. Doobie-doobie-doo. I'm wearing my glasses to do this, and I do have one of those ridiculous headpieces with magnifying glass on because I'm old. And because I'm old, I can't really see very well. And because I can't see very well, I need magnification. And I'm not doing this with my magnifying glasses, and it's a little bit harder. I don't know why. I'm not. No, that's gone badly. There we go. That's really ugly and not good. So what happened there? So that's bad. So let's not mess about. Bit of flux on that. see if we can fix it because it's ugly. So I think I haven't heated up the pin or the pad. One of them is not fully heated. When it does, the solder flows like kind of liquid when it's hot enough and it works. I wonder if that's a ground pin. Yes, it is. It is the ground pin. So ground pins again, causing me hassle. You can just reflow it though. There's a bit of flux and you're good. It is the ground pin because if you follow that trace along there, you can see it goes to the ground pin of that jack. So then we've got that one there. So these will all be ground pins. So let's use a bit more solder. Wait a bit longer. Make sure it's hot enough. That's the trick, isn't it? Where's it want? There it is. Yeah. Just got to be patient, haven't you? Be patient. So, all I've got left now is the jacks. Just to go down the jacks. So again, I'm just going to do just the ground pins. The reason I do this on these particularly is I have had it where I've bridged between those two pads, and then that's a short circuit right there. It's not good. It's not ideal. So if you just do the ground pins first, then by the time you get to the other ones, the ground pins will have cooled down. So you're less likely to get a solder bridge. I mean, you won't get a solder bridge, it's less likely. One more there. Oh, two more. Let's get some heat. There we go. And as I said at the beginning, I am not any measure good at this. I'm really not. I enjoy it. I like the challenge. I like the challenge of making a thing and then hoping the thing works. And then sometimes the thing doesn't work, and that's okay too, because then you got double whammy for your bang for your buck. So let's put this into context, because everyone says Eurorack is expensive, right? Like everyone will tell you Eurorack is expensive, Eurorack is expensive. But the reality is, bang for buck fun, it's not that bad, right? So this is costing less than an Xbox game. So I think the average price of an Xbox game, without like all the add-on bits and download content and season passes and all the rest of it, is probably about 50 quid, say. 50 UK. I think in America, in dollars, what's that? $58, $60 maybe? Something like that. So we're looking at about 50 quid. Well, this module has cost less than that. And okay, I've had to buy a soldering iron and all that kind of stuff, but you only buy that once. Like, once you've got it, you've got it. You can just keep using it. So the price of this module from Frequency Central direct, I think, was about 23 to 25 pounds, about $30 US. And then the price of the components, for me, actually, I already had them, so I didn't have to order any components because I buy things in bigger quantity. But the price of these components on this board is probably, because of the potentiometers and a TL072 chip and the jacks and stuff, I don't know, about 8 quid, something like that. Call a bit of shipping, let's call it a tenner. So what's that? About £35 UK, and in the US that's probably about $40 maybe, give or take. I don't know what the exchange rate is at the moment, but you know, $40. So it's less money than an Xbox game, this particular module, and of course some modules are much more expensive. I've had the joy of building it which, as I said, for me is kind of therapy. It's why I do it. It's not just about having a working module at the end of it. That's fine, but this is my therapy. This is my flow time. I just like doing it for no other reason than I like doing it. So I've had this time. So a few hours doing this. I mean, it wouldn't normally take me a few hours because I'm trying to do it on the camera. Well, I say that, I'm pretty slow. I am pretty slow. But I've had the joy doing it. Then if I've made a fault and I cocked it up, I'll have the joy of fixing it. Now that, don't get me wrong, that can be frustrating. Sometimes I need to take a break when I've cocked it up. If I've cocked it up and I can't find the fault, I do need a rest sometimes. I can't face it for maybe a few days or a week or something like that. Maybe I get back onto the online forums and ask some help. I had to do that recently with another Frequency Central build actually, and it was because I hadn't read the instructions properly because I'm dyslexic. So yeah, that's a thing. Yeah, do read the instructions properly. It helps. Yeah, so I've had the joy of building it and kind of doing all that bit. And then when it's in the rack, I'll have the joy of using it. And I won't just use it for a few hours like an Xbox game. I'll use it for many years. So actually, you know what? It's probably very good value. Probably very good value compared to other things. And we say it's expensive. Well, I mean, if you had to go out and buy your whole Eurorack thing at once, it would be expensive. No two ways about it. But if you do what I've done and you buy carefully, like I've never sold a module. I've never had to sell a module. I've got some modules I don't use so much, but I've never actually had to sell a module. And that's because I'm broke. It's because I'm broke. And when you're broke, every penny, every cent, every penny counts. And you can't afford to waste money with things that don't work. Now that means I don't have the cleverest, funkiest, most beautiful, expensive modules in the world in my rack. But that doesn't bother me in the slightest. I couldn't care less. Because it works. Because the great thing about Eurorack, modular, not just Eurorack, any modular, is it's modular, right? So generally stuff in your rack can do more than one job. So it's not like you build it and then you can't use it for something else. There's always something you can do with all this stuff. So yeah, there you go. That's my take on it anyway. You can do you. You can buy the big fancy expensive modules. You can lay out $5,000, £5,000 on a thing all at once. If that's you, that's cool. Don't resent that. Me, ain't got the money. Can't do that. Never had the money. Never will have the money. It's a hobby. It's not even about making music for me. It's about just the fun of building it and having something that works. If I can make some music with it, that's kind of like a bonus. It doesn't often happen. Let's be honest. I make noise like most people do. And then people say, oh, you've got Eurorack. It just makes a noise. That's all it does. And you go, well, yeah, that's fine. But people have got electric guitars that they just make a noise. Not everyone is Jimi Hendrix, are they? Do you know what I mean? Not everyone with electric guitar is Jimi Hendrix. Not everyone with a Eurorack is Daft Punk. But it's cool to try. It's okay to have some fun, have a play, mess about, think about it, come back. So by getting that panel on, it means that all the little knobby things work really, really nicely. Could do with doing a white dot on each of those. I will do that on this one, I think. Obviously I haven't tested that, so I'm going to go and get some. I can't really get some test equipment. I'm going to go and test it. If it works, I'll throw it in the rack, and then I'll follow this little video up with it working. My understanding is that this will output minus on here and positive on here, I think, and then this attenuates it. So you put your signal in there, and it comes out here. I don't really know. I'll have to work it out. The instructions say stuff, but I don't really understand it. But the point is, I need to be able to offset a voltage, and I think this lets me do it. If it doesn't, that's fine. It's another attenuator, it's another mixer. So you've got 3, looks like inputs. I think they're inputs. And then 2 inputs. And then an output and an output. And then this one's attenuated, and this one's attenuated. So you can mix, yeah. So you can put a signal in there, and mix the 2 together using the attenuator. Do the same on that, and then you get the output of that. So you could potentially mix 4, I guess. And then here you can mix 2, and you get an output. That one's got a minus volt, and that one's got a positive volt. And I think this one, when it's normaled, without a jack in there, it'll output a minus voltage here, I think. And then this one is normaled, so without a jack in it, it'll output a positive voltage, but we'll test it, find out. Anyway, there you go. Module done without the blue tack. Mostly quite neat soldering. There was just those electrolytic capacitors. They were a bit ugly, so I hope they're okay. But other than that, you can see it's all done. You end up with a nice little Gucci module to go in your rack. I was about to finish then, and I forgot something that's really important. And the really important thing I forgot is before you plug a module in, you need to check you haven't got shorts. And it's really easy to do. So, with your multimeter, get it into continuity mode. So again, with the little thing at the top, check your continuity meter, always touch the probes together. And then between this rail and this rail, you should not have a beep. So if it's all gone well, when I touch these, we don't get a beep. And we don't get a beep. That's the, that's the soldering station making a beep, but the multimeter is quiet. The 3 pins in the middle are all ground, so we will get a beep if we touch the 3 pins in the middle, which is correct, that's normal. So any of those 3 pins, they're connected together because they're ground, as you can see. But the 2 outer pins, the negative 12 volt and the positive 12 volt, no beep is good. No beep is good. You can also check between the positive 12 and the pin next to it, which is the ground. So check the ground, no beep, and you can do the same with the negative. So you shouldn't get a beep between the minus 12 and then any of the grounds. So we haven't got any shorts. So it's safe to plug that in. And I should have said that because it's worth doing that little check. It really is. Yes, I have blown modules up. Yes, I have had blue puffs of smoke because I've not checked or because I've messed something else up or I've plugged them in upside down, which is the thing you can do. So yeah, do check before you plug it in. There's no guarantee it will work, of course. If your soldering's a bit off or if you put a component in the wrong place, you know, you're going to have to problem solve then. Maybe I'll do a video on problem solving at some point. I'm not very good at it, but slowly getting better. There you go. So I didn't actually make a mistake with the soldering. I didn't make a mistake with the panel. Everything's in the right place and it kind of works. But what I did realise what I did realise is I'd forgotten something kind of essential. I guess it's essential. I mean, it kind of worked without it. So is it essential? I don't know. But I forgot to plug in the TL072. So that happened. That was a thing. So TL072, a little IC, and I've got a feeling it's an op amp, but let's find out. Let's just double check. I think it's an op amp, so it will work without it, but it probably needs it to be accurate. TL072, let's have a quick look. Low noise JFET dual op amp. Yeah, it is. So what that does, right, I think, and again, I don't understand the electricity. I don't understand the electricity stuff. But what I think it does is it amplifies the signal. It'll amplify the voltage. And depending on how you wire it up, will depend what you get at the output. leg. And I don't know whether you'll be able to see this, but there's a dot. There's a dot there. I'm trying to move it around so you can see it. And that dot is usually, I think it's the ground leg, I think. And to get these in the socket, there's a bit of a trick to it, which is to kind of bend the legs, because when they come out the packet, they'll be splayed kind of like out. And to get them in the socket, they need to be straighter. So if you take a straight edge, and I hope I don't mess this up on camera because I have messed it up before. If you take a straight edge and you just very gently just rock it down, you end up with the legs being somewhat more straightery to get it in the socket. Remember the notch? So the little dot is going to go at the notch end. Get it lined up and then just gently rock it into place. You have to be quite gentle with these, and I have messed them up in the past. So there we go. There's the little op amp in there, which it should have been in the first place. And some idiot left it out. What an idiot. What a moron. So do go and check out Frequency Central, frequencycentral.com. I'm not sponsored by them. Rick doesn't pay me anything. I don't get modules for free. I have to use my own dollar, which I don't mind, because I like to support his work, because I've loved building every single one of his modules. Even when I've cocked it up and made terrible mistakes, I've still really enjoyed building them, and I really enjoy using them. There's some great modules on there. I did a little video of Cosmic Background, which is kind of like an analog drum voice, but it will also work as kind of a wave, not a wave folder, sorry. It'll work as a filter as well. It's got its own filter, VCA, noise, it's got everything really. Cosmic Background is really good, and I might, when I can afford it, after Christmas maybe, if I can afford it, I'm probably going to build another one, because I really think it's great. Yeah. So I'm not shilling for Frequency Central particularly, but Rick is a lovely, lovely guy. I've finally seen his face. Been buying his modules for years, and he's decided to put his face on camera. It's a very brave move, Rick. Well done. But it is nice to see him, and what a top chap. I've always had great customer service, always with humour, despite my cock-ups. He's a very humorous, lovely chap. Oops. And sometimes the little PCBs have got messages written on them, which I love, and a really great member of the community. And that was the other thing I meant to say, is I talked about Modwiggler and Facebook, and those kind of forum-y type things. And yeah, you can get into a bit of an argument from time to time. That's part of the fun of it, I think. But the Eurorack, or the modular synthesizer, DIY synthesizer community is amazing. There's so many people giving so much of themselves to make it good. It's unreal, and I hope it continues, because it's an amazing space, really. Lovely people, always happy to help, and just amazing. So yeah, I'll try and film it working again. I did film it working, but I was filming it working without the op amplifier. So go and have a look, see what it does with the op amp. I mean, it worked. It kind of worked. But I guess it's not giving an accurate voltage, and it may not be inverting properly and things like that. So I'll go and try again, and we'll see. Yep, so in the other side it's inverting it, and I guess we can add in and all I've got going on there is just like an LFO. Well, it's not an LFO, but it's coming out of Rampage. In fact, actually Rampage has stopped. If I press the button, I'll get something else. We get a change in voltage. Don't think it offsets without a signal. Oh, maybe it does. It's definitely clipping, so it's amplifying it. Yeah, it does. So it offsets, which is what I needed actually. So that's inverting the signal, making it a negative offset. Perfect. And in the other hole, it should go the other way, shouldn't it, right? Yep, there you go. So that's making it positive. So it's boosting the signal. So really useful little module, really badly kind of hanging on a cable. It's not good, is it? Hanging on a cable like that. That's not right, is it? It's bad. But there you go. Yeah, there we go. Great little module.